When nonmetals bond with each other, they form covalent compounds. Chances are you already know many of these compounds because they're fairly common in nature. They include water and oxygen molecules. I'm sure these sound familiar. The difference between ionic and covalent compounds is that ionic compounds have atoms bonded together by transferring valence electrons, and covalent compounds have atoms that bond together by sharing valence electrons. But why do covalent compounds form? Let's have a look at a chlorine gas molecule, which consists of 2 chlorine atoms. We can see that each chlorine atom has 7 valence electrons, that is 7 electrons on the outside shell. And because of the octet rule, we know that they both want 1 more electron to make a stable outer shell of 8 valence electrons. Instead of giving and taking electrons between each other, which wouldn't give them both a stable outer shell, the atoms approach each other very closely so that the electron shells appear to overlap and their nuclei share a pair of valence electrons. When one pair of valence electrons is shared, it's called a single bond. Sometimes more than one pair is shared between the 2 atoms. In an oxygen molecule, for example, the oxygen atoms share 2 pairs of valence electrons. This is known as a double bond because 2 and not 1 pair of electrons is shared. This gives both atoms a full outer shell of 8 valence electrons. And a triple bond is formed when 3 pairs of valence electrons are shared. Covalent bonds are generally weaker than ionic bonds. This means that covalent compounds have much lower melting and boiling points than ionic compounds and often exist as gases at room temperature. They're poor conductors of electricity. Covalent bonds can be further divided into nonpolar covalent and polar covalent. Nonpolar covalent compounds share the electrons equally between the atoms in the compound. Polar covalent bonding results when atoms do not share the electrons equally. Some atoms are greedier than others. Chief suspects are fluorine, oxygen, and nitrogen. These atoms hold the electrons closer to their nucleus for longer. This results in these atoms having a partially negative charge since electrons are negatively charged. In turn, this causes the other atom in the bond to have a partially positive charge. These partial charges are much weaker than the charges that occur in ionic bonds, and so the Greek letter delta is used to symbolise the partial charges in the compound. Water is an example of a polar covalent compound. The oxygen atom in a water molecule has 6 valence electrons, and 2 hydrogen atoms have 1 each. If 1 pair of electrons is shared between each hydrogen atom and the oxygen atom, this gives all 3 atoms full outer shells. Note here that hydrogen only needs 2 electrons to fill up its valence shell, shell 1, not 8 electrons like oxygen. But remember that oxygen is greedy. It wants to keep any shared electrons closer to it. So while the electrons are still shared with the hydrogen atoms, they are shared unequally and spend more of their time closer to the oxygen nucleus. So the oxygen atom becomes partially negatively charged, symbolised by a delta with a minus sign. And the hydrogen atoms become partially positively charged, symbolised by a delta with a plus sign. So that's how covalent compounds form. Let's recap. Atoms in covalent compounds join together by sharing valence electrons. This is known as covalent bonding. Covalent bonds can be single, double, or triple, meaning that they involve 1, 2, or 3 pairs of shared valence electrons. Covalent bonds are generally weaker than ionic bonds. Covalent compounds have lower melting and boiling points than ionic compounds, often exist as gases at room temperature, and are poor conductors of electricity. Covalent compounds can be nonpolar, meaning that electrons are shared equally between atoms, or polar, meaning that electrons are shared unequally between atoms. The Greek letter delta is used to indicate the partial charges that form in a polar covalent compound.